There is a single mountain in South America that has bled so much silver into human history that entire empires rose on its metal. Global trade routes bent around it, and millions of lives were shaped and shattered because of it. Cerro Rico, translated to Rich Hill, has been tunnelled so relentlessly that today it no longer behaves like solid rock, but like a collapsing honeycomb riddled with tens of thousands of adits and shafts. Yet miners are still crawling through it in search of ore. From this one peak alone, on the order of 60,000 tonnes of silver, about 1.9 billion troy ounces, have been hauled out since the 1500s, a quantity that at today's price of 120 Australian dollars per ounce would be worth roughly 230 billion Australian dollars. That figure doesn't even include the tin, zinc, lead, copper and other metals that came along for the ride. This isn't just a famous mine, it is arguably the most metal-rich single mountain ever exploited by humans, a place where deep-time geology collided with imperial ambition, and where a long-dead volcano ended up financing one of the greatest empires in history. Long before any Spaniards set foot in the Andes, the story of this mountain began far beneath the Earth's surface. Around 13.8 million years ago, in the middle of the Miocene epoch, a mass of extremely hot, silica-rich magma started to creep upward through the crust beneath what is now Bolivia. This type of magma is called dacite, which simply means a thick, sticky volcanic melt that doesn't easily flow like basalt but instead tends to pile up. Rather than erupting in a towering ash cloud, the magma oozed toward the surface and inflated into a steep-sided lava dome, essentially a swollen volcanic blister that gradually pushed its way upward. As this dome grew, it fractured the surrounding rocks, shattered itself internally, and created a ring of fragmented volcanic debris known as a tuff ring and explosion breccia, which is just a fancy way of saying a pile of broken volcanic rock blasted outward during the dome's violent birth. This fracturing was the crucial geological accident that would later make the mountain extraordinary. The broken rock acted like a labyrinth of tiny cracks and pathways, a natural plumbing network waiting to be filled. As the magma beneath slowly cooled, it continued to release immense heat, driving superheated fluids upward through those fractures. These were not ordinary groundwater systems, they were hydrothermal fluids, meaning hot, chemically aggressive waters and gases loaded with dissolved metals. As these fluids moved upward and cooled, they began to deposit minerals inside the cracks, coating the fractures with glittering veins of silver and other metals. What makes this mountain different from most silver deposits is how perfectly the timing aligned. The dome was still cooling and shifting when the mineral-rich fluids arrived, so it kept cracking open again and again. Each new fracture allowed another pulse of metal-laden fluid to invade, stacking vein upon vein through the same body of rock. Instead of one brief mineralizing event, the system remained active for at least 200,000 years, an eternity in terms of ore formation. Over that time, the deposit became chemically zoned. A hotter core closer to the buried magma contained minerals like cassiterite, tin oxide, the main tin ore, wolframite, a tungsten mineral, and arsenopyrite, an iron arsenic sulfide that often carries tiny amounts of gold, while cooler outer zones accumulated sphalerite, zinc sulfide, galena, lead sulfide, and, most importantly, a rich suite of silver minerals such as acanthite and native silver. This is why Cerro Rico is so absurdly rich. Many silver deposits form in hydrothermal veins, but very few are tied to such a long-lived, repeatedly fractured volcanic dome that acted like a natural metal factory for hundreds of thousands of years. The mountain was primed from the start. The right magma, the right structure, the right fluids, and the right timing all stacked together in one place. For millions of years after its formation, the dome simply weathered in the thin Andean air, its volcanic rock slowly breaking down under wind, water, and ice. Indigenous peoples knew the hill as Sumaj Orco, meaning beautiful mountain, but there is no evidence they mined it extensively for metal. That changed abruptly in 1545, when, according to historical accounts, a local miner showed Spanish colonial authorities shiny silver outcrops gleaming on the slopes. Whether or not that exact story is perfectly accurate, what followed is beyond dispute. Within months, Spanish prospectors flooded the area, and within years, a massive mining city, Potosí, had sprung up at over 4,000 meters elevation. The discovery could not have come at a more pivotal moment for Spain. The empire was expanding across the Americas, fighting wars in Europe, and building fleets to dominate the Atlantic. Suddenly they had access to what would become the richest single silver deposit ever mined. Early miners quickly realized that the mountain contained extraordinary quantities of native silver, which is metallic silver in its pure form, along with silver sulfides like acanthite that could be processed relatively easy. This meant that even with 16th century technology, the Spanish could extract vast amounts of metal. The method they used was both ingenious and devastating. Ore was crushed by hand or with water-powered mills, then spread across large open patios, where it was mixed with mercury, salt, and other additives in a process known as amalgamation. Mercury naturally bonds with silver, forming a paste that could be collected, heated to evaporate the mercury, and leave behind pure silver. This technique, called the patio process, revolutionized silver production but poisoned the environment and the workers who handled it. Rivers, soils, and lungs absorbed mercury for centuries, a toxic legacy that still lingers today. Mining inside the mountain was equally brutal. The Spanish crown imposed a mita, a forced labour system that required indigenous communities to send thousands of men each year to work in the mines. Many died from cave-ins, exhaustion, lung disease, or mercury exposure. Tunnels were driven ever deeper into the hill, often with little regard for structural stability. Over generations, these workings multiplied into an unimaginable labyrinth. Today, if you could peel back the surface of Cerro Rico, you would find it honeycombed with voids. So much so that engineers have warned for decades that parts of the mountain could collapse catastrophically. Yet, despite the danger, mining never truly stopped. Even now, cooperative groups of small-scale miners descend daily into the same veins that first dazzled the Spanish nearly 5 centuries ago. They haul ore up by hand, using techniques that feel almost medieval compared to modern industrial mining. At the same time, larger companies have extracted tin, zinc, and lead from the deposit, taking advantage of the fact that Cerro Rico was never just a silver mine, but a complex multi-metal system. The sheer scale of the silver extracted is difficult to comprehend. Around 60,000 tons of metal, equivalent to about 1.9 billion troy ounces, have come from this single mountain. To put that in perspective, that is more than the annual economic output of many entire nations. During a height of Spanish colonial power, however, that silver was not measured in modern dollars, but in ships, armies, and influence. From Potosí, silver flowed in caravans to the Pacific coast, crossed the ocean, and arrived in Spain where it filled royal coffers. It financed wars against the Ottoman Empire, paid for the famous Spanish Armada, and allowed the crown to borrow vast sums from European bankers. But the silver did not stay in Spain for long. Much of it moved onward through Europe, paying for manufactured goods, mercenaries and debts, and a significant portion ultimately ended up in China, which demanded silver for its tax system. In this way, Cerro Rico became a cornerstone of the first truly global economy, linking the Andes to Europe and East Asia in a single metallic circuit. This wealth made Spain powerful, but also dangerously dependent. Rather than developing a broad, productive domestic economy, the empire leaned heavily on American bullion. When silver shipments slowed or wars drained the treasury, the crown repeatedly declared bankruptcy. The same metal that built the empire also helped undermine it over the long term. Geologically, the mountain continued to change long after the main silver veins formed. Near-surface parts of the deposit were exposed to oxygen-rich groundwater for millions of years in a process known as supergene oxidation, which simply means natural weathering that alters minerals close to the surface. This didn't dramatically increase the silver grade, but it did convert some sulfides into more easily processed forms, making parts of the ore more amenable to extraction and further extending the life of the mine. Compared to other famous silver districts around the world, Cerro Rico stands apart. Places like Fresnillo in Mexico or Cannington in Australia are immensely important, but they are regional districts containing multiple deposits. Cerro Rico, by contrast, concentrated an astonishing amount of metal into a single, coherent mountain. That is why most geologists and historians consider it the richest single silver deposit ever mined. Walking through Potosí today, it's easy to forget that this battered, eroding hill once powered a global empire. The modern city clings to its slopes, while miners still disappear into its dark tunnels each morning. Beneath the noise of trucks and the dust of centuries of excavation lies a story that began with molten rock deep underground, which was sculpted by superheated fluids, discovered by chance in the 16th century, and exploited with relentless intensity ever since. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.